Hello, this is Dr. Amudapriya, Associate Professor, EEE of Rohini College of Engineering and Technology, Pankulam. We are discussing about the power system analysis course, and this lecture is discussed upon the primitive network and the bus admittance matrix representation. What is a primitive network? It is a set of unconnected elements which provides information regarding the characteristics of individual elements. It can be represented both in impedance and admittance form. So here we can see the impedance form and the admittance form. How is it drawn? Simple. In impedance form we do have a voltage source, and in admittance form we do have a current source. Normally the bus admittance matrix, it can be obtained by two methods. One is a direct inspection method and the other one is a singular transformation. So we know y bus is equal to y12, y11 to yn. It's an n cross n matrix. By inspection method for n bus system, we have to find out the diagonal element of y bus, that is yii, which is nothing but the summation of j is equal to 1 to n small yij. For off diagonal elements, it is nothing but yij is equal to minus yij. So this inspection method, it is very simple. How we will calculate it? If suppose it is y11. So what you have to do is, for diagonal element, you have to find out the summation of all the admittances which are being connected to the first bus. If it is y22, then it is a summation of all the admittances which are connected to the second bus. Similarly, for off diagonal elements, we have to find out the bus, the line or impedance which is being connected from the first bus to the second bus. If it is y12 or y21, both are the same, y12 or y21, we will consider the impedance which is connecting the first bus and the second bus. Its negative value is the off diagonal element. In this way, we can find out the bus admittance matrix. Second method is singular transformation method. By singular transformation method, the formula is y bus is equal to A transpose YA, where y is the primitive admittance and A is the bus incidence matrix. Here we can see the calculation for the formation of the bus impedance matrix. Z bus, we have to find out the Z bus value, and then only you can find out the y bus value. First, we have to go for the modification of the Z bus matrix, and it involves 4 different cases. For the first case, adding a branch impedance ZB from a new bus to the reference bus. So adding the new bus will increase the order of Z bus matrix by 1. So Z bus new is equal to, we used to have an original Z bus value to which the row will consist of 0 and the column will have a 0, and finally we have the diagonal element as ZB, which is being added. The n plus 1th column and the row elements are 0 except the diagonal element to be ZB. For case 2, adding a branch impedance ZB from a new bus P to the existing bus Q. So adding the new bus will increase the order of the Z bus matrix by 1, and the elements in the n plus 1th column and the row elements are the elements of the existing bus, and existing bus column and row, and then the diagonal element will be ZQQ plus ZB. The existing bus diagonal element plus the added one ZB. Case 3, adding a branch impedance ZB from an existing bus to the reference bus. So when we are going for that, obviously the elements of n plus 1th column and the row are the elements of the qth column, the existing bus qth column, and the row and the diagonal element is ZQQ plus ZB, and n plus 1th row and column should be eliminated. We have to go for this because we are going to consider the existing bus and the reference bus. So an already existing one has to be removed, and only after that we can go for this. This is a formula. And at the last, adding a branch impedance ZB between existing buses, two buses H and Q. The elements of n plus 1th column are elements of bus H column minus bus Q column, because both are the existing buses, and the row is also the same. Both the rows have to be subtracted, and that value will be the n element of n plus 1th row. Similarly for that. And the diagonal element is ZB plus ZHH plus ZQQ minus ZQH. And the n plus 1th row and the column should be eliminated using the above set formula. Thank you.